Everyone, and welcome to LS Telcom's showcase session using big data from RF monitoring to build a continuous map of the spectrum environment in urban areas. My name is Philipp Abel. I'm your speaker for today. I work at LS Telcom as a product manager in the field of spectrum monitoring. So what I mean with spectrum monitoring is the measurement, visualization and analysis of the RF spectrum. Typical task of spectrum monitoring is to identify and to localize interference, for example caused by unlicensed emitters, jammers or other artifacts like intermodulation products. Other task is to look at the spectrum usage, to look at overloads in white spaces, to make so-called spectrum occupancy measurements, to see the utilization channel by channel. And then to make coverage and quality of service measurements to compare the theoretical calculation with the reality. The same with to verify transmitters. Are they acting according to the theory, to the database in spectrum management, or do they act in reality different? Typical modern spectrum monitoring system consists out of multiple sensors distributed over urban areas. They consist out of fixed, mobile, portable units and include typically high-speed sensors which capture a really wide measuring range, for example 9 kHz up to 18 GHz. The modern way of monitoring comes along with some challenges. Those high-speed sensors produce really massive waves of data and this 24/7 permanently. This amount of data, really big data, cannot be analyzed by a few human operators. It can only be analyzed by machines, so how to make use out of this data is for sure that you have some software which is able to aggregate the data in an intelligent way, which is also called often data mining. That means to make from the raw data, from the raw measurement data, something useful which can be understood and can be read by humans. So to visualize the data then in a human readable format, to make use out of it. And this is called spectrum mapping. So what is spectrum mapping? If you look at the picture I'm currently pointing it, this is an analysis of a drive test from spectrum monitoring. A typical view where you can see the field strength along a route in a visualization of dots or a line. So you can compare for a service the different field strengths you can capture at different locations to evaluate if the service has coverage at a certain location or if there are white spaces. If you do this for many routes and many blocks here in urban areas, like you can see here on Shanghai, you get such a picture. Really confusing for the user, I would say. You have a lot of dots, a lot of lines, but what if you want to know what is the coverage here on this point or on this point where you don't have actually data? You don't know directly. You need somehow to interpolate with your eyes what could be the field strength there. So now spectrum mapping comes into place. What our solution spectrum map does is to combine monitoring data from drive tests, from fixed monitoring station, from other station like portable or even flying monitoring units. It takes all the data together for the entire spectrum of interest and then presents the user with a continuous map. the continuous map is achieved by intelligent interpolation algorithm which spectrum map uses. By this, the user can directly see the spectrum for the channel or service of interest for his urban area. It is a really meaningful and powerful picture for spectrum management and offers various applications. So how does it look like in our spectrum map solution? The spectrum map GUI is browser-based. The processing, the backend is running on a server which can be also a cloud computer. How does it look like in the GUI? You just open your browser, type in the login details. Then you can select the area where you want to create a spectrum map for. Then you select which kind of spectrum map you want to display and select which service or channel you want to display. Now we want to select GSM-R for the railway. And here we can see now the field strength distribution. Red means higher field strength, blue means lower field strength. And we can see along the railway there's higher field strength. At any time you can adapt the scaling. You can also display a coverage map where you can simply see which areas are for the service covered or which areas are not covered. Then you can also display the dynamic channel view where you can simply slide through the channels of a specific band and see the spectrum for each specific channel step by step. All channels and bands can be predefined, and this slider is not only available for dynamic channel view, but also for dynamic time view. So you can see how the spectrum changes day by day. For example, how it looks on weekdays versus how it looks on weekends. So what are the use cases of spectrum map? If you at one side look at the coverage, so at the downlink, you can view, for example, the total availability of 5G. So you can see at which areas 5G in general is available. But you can also look at the individual view to the different providers. So which provider does provide best 5G coverage in which area? 5G now was only an example, but for sure for any other services, cellular services, PMR, Tetra, IoT, just a few examples to mention. Then you can look also on the other side. If you look at the uplink, at the frequency usage, you can evaluate areas of high and low dense usage and by this identify overloads. And really important, you are able to identify and localize interference or illegal spectrum usage without needing any classical localization features like direction finding or time difference of arrival. It is just from interpolation, from fusing of massive big data. And by this, as you can display the license stations with your spectrum map, if you have a hotspot, a red spot where no license station is, it could be, for example, interference or illegal spectrum usage. With spectrum map, as previously mentioned, you can compare the spectrum for different days, so you can see spectrum usage trends over time. Spectrum map gives a really great tool for spectrum management, for decision basis, for frequency assignment and reallocations. So you can see for a new assignment if the band is safe to use based on the real measured parameters, not only based on the theory. You can see if a band is not used according to its license agreement. You can think about reallocation. You can also make use out of modern concept like spectrum sharing. So if, for example, one company on one side of the city can use the same band like the company on the other side of the city, you can use it, you can check this and verify it with Spectrum Map. And last but not least, Spectrum Map offers the possibility to build a radiation map to see if radiation limits are met and to identify potential radiation hazards to human, to evaluate if the human exposure is okay in all areas, to prove to the public. So before you always saw the project in Shanghai, now I want to give you insight to another really impressive project we did in the modern city of Dubai. Here we use the combination of our LS Observer Spectrum monitoring solution with our Spectrum Map solution. LS Observer consists of different hardware to measure the spectrum and a central monitoring software. Here we used a portable unit of the LS Observer, put it inside just a standard vehicle, put a small antenna on top of the vehicle with a magnetic base, and drove along the city entire day, 6 hours 30. We measured 80 megahertz up to 6 gigahertz with a fast scanning and high resolution receiver, which produced for this day 268 gigabytes. We drove several days, used the data and combined it later. The really innovative thing of this combination is once the vehicle has done its drive test, all the data is automatically backed up and transferred to a server, and the data is then deleted from the measurement unit to have enough storage again for the next measurement. And on the server, all the data is processed by Spectrum Map and then can be visualized on the browser by the operator. Now I want to give you more insight to this. So we used the LS Observer protected portable unit. This is a ruggedized portable unit which you can easily integrate inside a vehicle. It can be powered just from the vehicle outlet, or alternative, it includes also with batteries with 3 hours runtime which can be swapped. It includes a large internal storage, so perfectly suited for this use case, and the option of auto recording. What does it mean is that a monitoring expert can predefine the measurement parameters before the drive, and then the drive itself can be simply executed by someone who's only responsible for the driving, who is not a monitoring expert. He doesn't need to touch the unit. The unit will automatically run its recording job in the defined area. So as a user, in the LS Observer CMS software, where you can control the units, you simply define the area for the recording, you define the measurement parameters like frequency, range, and further receiver parameters, and then the recording job will be automatically initiated once the driver reaches the area which you defined here. And after the drive, when the driver comes back to the head office, all the data is automatically transferred, in this example via Wi-Fi, to the server and then automatically processed by Spectrum Map. So no interaction needed. The user simply needs to go to his laptop or computer, access the browser, and see the measurement results in Spectrum Map. To sum this up again, here you can see the process circle for this use case. So A measurement expert, an operator, can predefine the measurement parameters, the recording job, and then a driver simply makes the drive test. The measurement is initialized when the area of interest is reached. The driver does not need to interact with the unit. And after the drive, the measurement data, again without interaction, is automatically uploaded to the server, for example via Wi-Fi or via LTE or 5G. Then once the data has reached the server, the data is deleted on the PPU on the monitoring unit, that it has again free storage from the next drive test. And then the data can be analyzed also by our CMS, our central monitoring software, if you want to look at detailed in the spectrum versus frequency versus time view. Yeah, if you don't want to analyze not only maps, but if you want to see in detail, for example, the signal characteristic of interference. All the data is automatically processed by Spectrum Map, mined together, and then the user is presented with this unique spectrum maps. They can choose between different spectrum maps for all his channels or bands of interest and can analyze it. So as I introduced already one LS Observer unit on the previous slide, I want to give you a short overview about the sensor-based automated spectrum monitoring system from LS Telcom, the LS Observer. Here you can see a typical spectrum monitoring view. This is a screenshot of the LS Observer CMS software, a power versus frequency chart with a linked waterfall chart. This classical spectrum monitoring we for sure support with LS Observer, but LS Observer is more than this. We have sophisticated features like AVD, automatic violation detection, where the system automatically and permanently compares the live measured spectrum with the user-defined reference spectrum, so the theory from spectrum management. And in case of any anomalies, for example interference, illegal spectrum usage or emitter outages, it will automatically trigger an alert. And once you have such an alert, you want to know where does the signal come from. And this is also supported by LS Observer. It offers multiple technologies to localize an emitter, for example by using direction finding, time difference of arrival, or gain ratio of arrival. Here you can see the hardware portfolio of LS Observer. We have units for fixed monitoring, fixed permanent monitoring, for temporary fixed monitoring, mobile monitoring, portable monitoring, and even we have a flying LS Observer, a fully integrated drone-based solution where you can make measurements from the air. All those monitoring units can be networked together and centrally controlled and remote controlled by the CMS software. Here you can see a typical regulator network where you have different kind of stations, everything networked together and centrally controlled. LS Observer is highly automated. Our monitoring units can permanently record the entire spectrum of interest on its local storage. So all units include a large local storage before you need a backup. They can automatically perform AVD. By this, alarms are triggered and then the alarm source can be localized. For example, in the case of interference, where does the interference come from, to be able to immediately react on it. On the last slide, I want to give you an outlook to the future. So currently we have for the spectrum map, we collect the data with dedicated vehicles or combined with fixed stations. But spectrum map really lives from the high density of data. And if you look at public transport or public services like buses, taxis, garbage trucks, they anyhow drive around the city the entire day, day by day. So why you need a special fleet for spectrum monitoring? You can just use those public services and you get a really high data density day by day. And that's why we want to develop into this solution to be able to integrate into those public services spectrum monitoring equipment and to be able to upload then the data to the server for spectrum map processing. And here you really measure, that's also one of the advantages of spectrum map. You measure at the street level, you measure at the user level, you measure there where the actual users are, and you get a really precise picture of the spectrum. And by this, I want to finish my presentation and I want to thank everyone for your attention. If you now have questions or you want to have a detailed demo to Alice Observer or Spectrum Map, just contact me via the email I put here on the slide. It's pubble@alicetelcom.com. Thank you and see you soon.